Your right boot sinks into ground blazing at over 250 degrees Fahrenheit. Your left boot, planted inches away, rests on regolith colder than any winter Antarctica has ever recorded. One stride separates boiling heat from bone-deep frost, and your suit has less than a second to answer both extremes at once. One boot in sunlight, one boot in shadow, and the temperature difference between them is enough to fry one half of your body while freezing the other solid. Nothing on Earth prepares a human nervous system for this line in the dust. The boundary sits directly beneath your feet, sharp as a blade splitting the ground into two separate planets fused at a single seam. Regolith bakes under direct sunlight, absorbing solar radiation with no atmosphere to soften the blow. Grains of lunar dust hold heat like a furnace, radiating temperatures that would boil water within seconds of contact. Your visor tints automatically, filtering a sun that burns 7 times brighter without an atmosphere to scatter its glare. Sweat forms on your back inside the suit, a normal human response to heat that the surrounding vacuum will never register. Every photon striking the ground transfers its full punishing energy directly into the surface, unblocked, unfiltered, unbothered by air molecules that don't exist here. The right side of your visor fills with white glare bouncing off crushed volcanic glass and anorthosite. Your glove brushes a rock, still radiating warmth absorbed over the past 2 lunar day weeks, each one stretching nearly 354 Earth hours long. Shadow falls 2 feet to your left, cast by a boulder the size of a delivery truck. Darkness there carries no relief, no cooling breeze, no gentle drop in temperature, the way shade behaves back home. Lunar shadow plunges instantly to nearly -133 degrees Celsius, a cold that would flash freeze exposed skin in moments. Permanently shadowed craters near the poles sink even further, reaching almost -246 degrees Celsius, a cold that rivals the frozen sunless surface of Pluto. Your boot's outer sole, built from silicone rubber and layered insulation, meets that shadowed ground and immediately starts losing heat through direct conduction. Metal fasteners on your suit's exterior contract audibly a faint ticking sound transmitted through your own bones as materials shrink in the sudden cold. Your training warned you about this exact boundary, yet standing inside it, the disorientation still floods every sense at once. Light and dark exist here as absolute states: sunlight, or absence, heat, or annihilation, with no dimmer switch between them. Air does the invisible work on Earth, constantly circulating warmth between light and shadow, blending both zones into one breathable, survivable climate. That blending never happens here. The Moon's exosphere holds so few molecules that heat has no medium to travel through, no wind to carry it, no humidity to spread it evenly across the terrain. Every childhood memory tells you that shade brings comfort, that stepping out of direct sun offers instant relief from a beating heat. That memory becomes a weapon against you the instant you cross into lunar shadow without your suit's active systems fully engaged. Human skin evolved across millions of years on a planet where a light breeze always tempered any extreme, where clouds softened the sun and night air still held daytime's residual warmth. Nothing here softens anything. The boundary between sunlight and shadow behaves like a wall, not a gradient. A wall with matter frozen solid, pressed directly against matter, hot enough to blister flesh through fabric. An astronaut's instinct, wired by evolution to seek shade for relief, becomes catastrophically wrong the moment it triggers on airless ground. Stepping fully into that shadow without preparation exposes an unshielded hand or face to cold severe enough to cause frostbite within seconds. Reaching instead into direct light without the suit's reflective outer layer risks scorching exposed material past its thermal limits within moments. Neither side offers safety on its own. Your entire survival depends on refusing to trust the very reflex that kept your ancestors alive under every sky on Earth. Sensors embedded across your suit's surface report both temperature extremes in real time, feeding data into a portable life support backpack strapped across your shoulders. That backpack becomes the only thing standing between your body and 2 entirely different forms of death occurring 3 feet apart. Picture the seam itself stretching across the crater floor like a line drawn by a ruler, not by nature. Dust settles differently on each side, sunlit grains appearing brighter, sharper, almost glowing under direct exposure, while shadowed grains sit dull gray and utterly still. Your own shadow stretches long and razor-edged across this terrain since no atmospheric scattering softens its outline the way Earth's sky does at dusk. Standing exactly on the boundary, one leg absorbs punishing radiant heat through the suit's outer shell, while the other leg bleeds warmth into ground, acting like a heat sink, pulling energy directly from your body. 14 layers of material stand between your skin and this violence, most of them invisible from outside the suit's white outer shell. A liquid cooling and ventilation garment presses against your body, first spandex mesh threaded with roughly 91 meters of thin plastic tubing, carrying circulating water. That water absorbs metabolic heat generated by your own muscles, moving it away from your skin before it can accumulate into dangerous overheating. Layers of aluminized mylar, laminated with Dacron and Gore-Tex, wrap around that inner garment, forming a barrier that reflects solar radiation while trapping your body's own warmth like a thermos sealed against space. Your suit isn't reacting to the moon's temperature at all. It's building its own tiny, self-contained planet, 3 feet of engineered climate wrapped directly around your skin. Engineers who designed this system rejected the idea of fighting each temperature extreme individually, since no single material could handle both fire and ice simultaneously. Water circulating through those tubes carries excess heat away from your torso and limbs, routing it toward a sublimator in your backpack that vents it safely into vacuum as vapor. That process converts liquid water directly into gas, skipping the usual boiling stage entirely because pressure inside the suit sits far below what Earth's atmosphere maintains. Heat leaves your body through this engineered channel, while the suit's outer shell simultaneously blocks incoming solar radiation from ever reaching your skin. The genius here isn't resistance. It's redirection, moving heat exactly where you need it removed, instead of trying to block it outright. Every layer works together: insulation trapping useful warmth, reflective coating deflecting punishing sunlight, circulating water hauling excess heat toward the sublimator for safe release. Your suit becomes a portable climate system, capable of holding steady internal comfort while its exterior spans a 400 degrees Celsius range within a single stride. That epiphany reshapes everything you thought you knew about surviving extreme environments. Fighting the moon's temperature directly using massive insulation alone would demand suits too heavy and rigid to allow any movement across the surface. Building a self-regulated internal climate solves the problem from the inside, ignoring the external chaos almost entirely once the system engages. Apollo astronauts wearing these suits walked confidently across boundaries just like the one beneath your boots, trusting engineering over instinct at every single step. Your pulse slows slightly as the readouts stabilize, confirming both legs sit within safe operating temperatures, despite the wildly different ground beneath them. Consider the sun itself, sitting 150 million kilometers away, yet still capable of creating a thermal weapon this precise on a world with no air to soften its reach. Distances at this scale defy ordinary intuition, collapsing enormous cosmic gaps into a single punishing beam striking bare rock. Meanwhile, the shadow beside you channels an equally extreme cold born from a total absence of atmospheric blanket rather than any deliberate hostility from the universe. Both extremes emerge from the exact same missing ingredient, air, revealing how one simple absence reshapes every rule your body has ever relied on. Earth's shade taught you safety. Lunar shade demands a completely different kind of trust, built entirely on machinery rather than memory. That shift defines every surface mission ever planned beyond our home planet. Astronauts walking toward the moon's south pole, where NASA's Artemis program aims to establish sustained human presence within permanently shadowed craters, will cross boundaries even more extreme than the one beneath your boots today. Those polar shadows hold frozen water ice, a resource valuable enough to justify building habitats directly beside cold, capable of matching Pluto's darkest depths. Engineers are already designing next-generation suits with improved cooling loops and radiator panels specifically to handle these permanently shadowed zones, pushing survival technology further past every instinct evolution ever gave us. Mars rovers and future crewed landers will face their own version of this same paradox: thin atmospheres offering just enough pressure to behave unpredictably compared to both Earth and the Moon. Every world humanity reaches forces this same lesson relearned again and again across different terrain, different atmospheres, different killing gradients. Shade will never mean safety anywhere beyond Earth's sky. Each new landscape hides its own version of this seam, waiting to punish any explorer who trusts old instincts over new instruments. The boundary between light and dark on the moon reveals something larger about the universe itself, an endless collection of thresholds where human perception fails and human engineering must take over instead. Standing here, straddling boiling ground and frozen shadow within a single stride, you feel the full weight of that truth settle directly into your bones. Somewhere beyond this crater, countless other boundaries wait across worlds no human has ever touched, each one holding its own impossible seam between survival and disaster. Each one demanding that we abandon what feels true and trust, instead, what we have built to keep us alive.